Hope my screen is visible to everyone.
Yes, sir.
Is everyone there in the class? Yes, Gauri, Chakrika, and Aleph, you guys are there. Okay. So let us quickly recap whatever we have discussed so far. Okay. Meanwhile, before we continue with what we have discussed, I would like to ask some questions from the previous topics. Okay. So first of all, you guys tell me what is the use of a lightning conductor? Why do we use this lightning conductor?
The lightning conductor helps the a lightning to go into the earth.
Hmm,
Earth.
okay. So thereby it will be protecting the buildings. Yes.
Yes, sir.
Okay. All of you turn your cameras on in the class. Okay. Also tell me about this thing also, like why lightning would be usually striking the tall buildings.
So because lightning finds the shortest way to reach.
It looks for the shortest pathway. So the air gap between the between the tall buildings and the lightning is very less. Okay, now. So the air gap between the building and lightning is very short, very less. Hence, they are more susceptible to lightning. Okay, good. Okay. Also, to tell me, whenever there is a lightning, the ground acquires positive or negative charge. Whenever there is a lightning, ground ground is positively charged or is it negatively charged? Yes. Yes, Aleph, Chakrika, and Gauri. Look at this.
So,
Uh-huh.
is it positive?
It's positive, correct. Okay, Aleph. So you have some network issue sometime. Okay, no issue. Sometime it happens, then that is understandable. Okay, na. Anyways.
Okay,
Ha.
sir.
Also, what basically happens now, as you guys can see in this also, in this animation, you guys can see here that I think it should be clear that what is the whole procedure, like why does lightning form? What basically happens here? Huh? The hot air moves upward while the raindrops are falling downward. Because of that, charges get separated in the atmosphere. And as a result of that, what happens? The negative charge gets accumulated in the lower part of the cloud, positive in the upper. Okay. It is happening due to the friction between the hot air and the raindrops. Getting it? And furthermore, if the wind speed increases, the charges multiplies further. The magnitude of charges increases. And there comes a time that magnitude of the charge increases too much. So thereby, although we know that air is a bad conductor, but it is forced to charge it is unable to restrict the flow of electric charge after some time, because the magnitude of charge that has generated is too much for it to hold. So we had learned about these things. And also lightning can occur within the cloud, between the cloud and the ground, and between two clouds also. So these things we have learned. Okay. And in the case of electroscope, as we were learning in the case of electroscope, so you guys can also make a electroscope at your own. Okay, now using simple method, we can also make an electroscope. Okay. All you had to do, just 1 minute, there's some issue. Let me connect to this once again. Am I visible?
Yes, sir.
No, my camera might have been stuck. Just 1 minute. Huh. What I was going to say now, like you can also make an electroscope at your own. Like this question might be asked in the exam. Write down the steps to make an electroscope. Okay. So all you have to do, you have to take a empty glass jar. You have to take an empty glass jar. You have to take, like you can take any metal plate. Okay, now you can take any circular disc shaped metal at home. Okay, now you can cut it from any given piece of metal. You have to take a rod like this. Okay, and at the end of this now, what you can simply do, you can just take a rod like this, make a hook shaped rod, and at this now you can take simply 2 sheets of paper. Okay, now like we can't afford to have a gold leaf now, right, Chakrika? So you can just take two pieces of paper
Yes,
and
sir.
just hung it in this, just hook it in this. Okay, now all the setups would be same. Simply just you have in place of these gold foil leaves, you have to take two sheets of paper, and they should be loosely hung. Like you can take two separate pieces of paper. So in this manner, we can also prepare. We can also make an electroscope. Okay, now so making an electroscope is very easy. We can also do this. Okay, following some simple steps, we can make a electroscope. All right. So today we are going to continue with earthquake. In this, we were learning about few terminologies. Okay, moments ago I was asking some question. Okay, you guys tell me that what is epicenter? Yes. What is epicenter?
Sir, epicenter means like that is which uh, less shaking is happening.
No, that's not what epicenter is.
So epicenter is like the surface
Center of
is exactly above the force.
Okay, like it's basically a vertical point that is right above the focus. Okay,
Yes, sir.
it's a
Focus.
word right above the focus. Okay, so we learned about this. And in what manner earthquake travels? Earthquake travels in the form of waves, no?
Yes, sir.
And we call that wave as seismic waves. Okay, now we call that as seismic waves. Yes, Roni, how are you? Roni, you were absent in the previous class. Okay, okay. Please be regular. Okay. Huh. So in the case of earthquake, as we were learning few important things, like it is basically the trembling of the earth, sudden shaking of the earth because of some activities going on inside the surface of the earth. Okay. Also, it's very unlikely to predict the earthquake very accurately. Okay, now like meteorologists, they can predict thunderstorm and cyclone, but it is difficult to predict this. Getting it now? It is difficult to predict earthquakes. Furthermore, we learned about few other things like earthquakes can lead to loss of life, loss of property. It that does lots of damage to public properties like buildings, dams, and bridges, etc. It can also trigger flood, landslides, and even tsunami. And we have to learn about tsunami in the chapter. Okay, we were learning about the movement of the plates also. So we did learn that our crust is not a single mass, but it is fragmented into different sections. Okay, now it is divided into different fragments. Right now, some of the fragments are big, some of them are smaller. So those fragments are called as seismic plates, as you guys can see here. There are several seismic plates on Earth. Getting it? So the crust is divided into different seismic plates. And these seismic plates are kind of floating above the mantle right now. The seismic plates are floating above the mantle. The mantle is heated because of the heat coming from the core. So it is heated, and because of heat, convection current develops in the magma, in the mantle, I mean to say. So mantle is continuously moving, and because of that movement, the crust above it also moves. Okay, now, but although you will not see, you will not actually feel the movement unless there is an earthquake. So every year the plates are moving, they are colliding into each other few millimeters every year, or at some places they are moving away from each other, meaning that at some places the crust are colliding into each other, I mean to say the plates are colliding into each other. At some places they are moving away from each other. So every year about few millimeters, not like a meter or a kilometer. Every year, these plates would be moving away from each other by few millimeters. Getting it? Okay. Also, you guys would have learned of this, like the height of Mount Everest increases by few millimeter every year. Like right now, it's 8,849 meter. That's the height of Mount Everest, right? By the way, where is Mount Everest? Yes, is it in India or is it in Nepal? It is in Nepal. Okay. Right now, this is the height. But the thing is that height of Mount Everest is increasing. So why is it increasing? Like it is estimated that every year it grows by 4 millimeter. Every year it grows by 4 millimeter. So 3 years from now on, the height would have increased to 1.2 centimeter. So after 3 years from now on, you would be learning that the height of Mount Everest would have increased to 8,850.2 meter. Getting it what I'm trying to say, Chakrika, Alif, Gauri, and Roni?
Yes, sir.
So the reason here is that as the two plates are colliding, like if you guys were to see this now, like this Indian plate and the Eurasian plate, these plates are colliding into each other. Because of that, it leads to rise of the height of Mount Everest. These plates are colliding into each other. And here is the Himalaya in which the Everest mountain is situated. Mount Everest is situated. Got my point, what I'm trying to say. But at some places, these plates will be moving away from each other. So that is the thing. Okay. Furthermore, we were learning about the fault zones, or also called as seismic zones. So seismic zones are basically it's kind of those zones on the earth where the plates are more likely to collide or move away from each other. Like here at this zone, those plates will be colliding into each other. So thereby this zone will be considered as a weak zone where earthquakes are most likely to occur. Okay. We also learned that there are some countries like Japan, it's the country to have been hit by most earthquakes. Okay, now apart from Japan, countries like Indonesia, which is over here. This is where Indonesia is. Getting it, guys?
Yes, sir.
Indonesia, Malaysia, all these countries are here. So they are also more likely to be hit by the earthquakes. Why? You can guess it, because they are in the weak zone. They are lying in the weaker zone. That's why. So countries like Japan, Indonesia, they are more likely to be hit by earthquake. So that is the thing. Okay. Then we learned about some of the other causes of earthquake also, like volcanic eruption also causes earthquake. Okay, no? That also leads to earthquake. So you guys would be having slight idea about volcanic eruptions. What basically happens when too much of pressure accumulates inside the earth? Like here, this is molten magma. This is molten magma, and this is called as magma chamber. This is called as magma chamber. So when too much of magma accumulates at one place, so it will look out for any crack in the crust from where it can come out. So gradually over so many years, it will lead to rise of the crust, and eventually when the pressure accumulates, too much of pressure is generated, it comes out in the form of volcanic eruption. Right now, so this will also move the plates now, as you can see, cracks develops in the plates. So that will also trigger earthquake. Other reasons where when a meteor hits the earth surface, that also leads to earthquake. Okay, also nuclear explosion under the earth surface, that is also said to have caused earthquake. But although those earthquakes are not of that much, like they are usually weaker earthquakes. Okay, now, but they can cause earthquake. In fact, they have caused earthquake. Okay, so there can be earthquake due to nuclear explosions also, but the magnitude is not that much significant to destroy life and property. Also, whenever nuclear tests are carried, so most of the nuclear tests would be carried away from the densely populated area. Mostly it will be carried under the oceans or the seas. Got my point? Also, as we will learn in the previous class, that it's not that earthquakes occur only in the earth. It's not like seismic activities are only seen in the case of earth. Seismic activities occurs in other planets also, like in the moon. For example, Chandrayaan 3, it was sent to the moon last year, right? So Chandrayaan 3, this detected about 250 moonquakes. How much? About 250, more than 250 moonquakes were observed in the moon. Getting it, guys? So this seismic activity is not just limited to Earth, but will be observed in other planets also. Furthermore, we learned about there's a barren island. It's a island situated in Arabian Sea. It's the only active volcano in India. We know that volcanoes are of different types. They are dormant volcano, they are active volcano, and they are extinct volcanoes. Getting it now? So India has all three types of volcanoes, and the only active volcano that is there in India, that is situated in Barren Island, and this is in the Andaman Sea. We also learned based on the cause, there are different types of earthquakes. Okay, now, so most of the earthquakes are caused due to the tectonic movement. Like these plates, they are also called as tectonic plates. These seismic plates, we also call them by the name of tectonic plates. So whenever these plates will be moving away from each other or moving into each other, that will lead to earthquake. Also, talking about the power of the earthquake. So the power of the earthquake will be expressed in terms of magnitude on a scale, and that scale is called as Richter scale. An earthquake which has a magnitude equal to or more than 7 on a Richter scale, it is considered as destructive. Have a look at this Richter scale. Okay. So here you can look at the different numbers like 1, 2, 3 till 10. So say that like the earthquake with magnitude 1, it occurs almost daily. Earthquake with the magnitude 1, 2, 3, or 4 on the Richter scale, it will be occurring on a daily basis. And in fact, like the earthquake with magnitude 1 occurs every minute. Getting it? This minute also, right now we are having this class at this moment also, like we had our class for the class has started about 20 minutes ago. So far there have been 20 earthquakes with the magnitude 1. Getting at what I'm trying to say? So movement will be very small. The movement of the plate will be very small, so thereby it will not be very destructive. All if you turn your cameras on in the class. Similarly, you can look for other earthquakes also, like the earthquake with magnitude 2, 3, and 4. So they will also be occurring on a daily basis. So these data is not really that much important, but just the important thing is when you look at these earthquakes, now earthquake of the magnitude 5, 6, 7. Okay, so the movement will be strong and sudden, and these will be destructive. Earthquake, particularly with magnitude 7 and more than that, will be highly destructive. Okay, now highly destructive. Also talking about earthquakes like with magnitude 9 or 10, they are very rare to occur. Okay, now they are very less likely to occur, and as per the data, they might occur every 300 years. While the earthquake with magnitude 10 on the Richter scale, it might occur every 1000 years. And the movement of the plates will be extreme, and it will wipe off a big number of population. Getting it, guys? Another important thing is that each level is 10 times stronger than the previous level, meaning that the earthquake having a magnitude of 2 is 10 times stronger than the earthquake with the magnitude 1. Got my point now? Here's Gauri, Chakrika, Aleph, Roni, everyone.
Yes, sir.
So can you explain again?
Yes,
sir. Okay, which point in this? This 10 times is stronger or any other thing?
So the 10 times stronger one.
Okay. 10 times stronger here means now, like there's an earthquake with the magnitude 1 on Richter scale. Okay. And there's an earthquake with the magnitude 2. Numerically, the difference is 1. So we can say it is 1 plus 1, 1 times stronger. Okay, now if you were to look at the difference of these two numbers, there's a difference of 1. But in terms of magnitude, in terms of the destruction it will cause, in terms of strength, this is actually 10 times stronger than the earthquake which with magnitude 1 on Richter scale. Okay, now it's not 1 time stronger, but 10 times. Similarly, if there's earthquake of magnitude 2 and 3, so the earthquake with magnitude 3 will be 10 times stronger than the previous one. That is what it means. Getting
Yes,
it or not?
I get it. Yes.
Good. And we had learned about these things, focus and epicenter, in the previous class. Like focus was the point inside the earth where the earthquake will be originating. Okay, now an epicenter is the point that lies just above the focus of the earthquake. It lies vertically above it. So the destruction will be maximum at epicenter. Okay, now, and this is the fault display. Okay, now, like as the plates have moved past one another like this, so there will be a fault here. Okay, now, where huge pieces of rocks would have moved away from each other, which we can see here. Also, like you guys know about this thing, like Africa is splitting into two parts. If you would have heard of it or no, but scientists, when they learned about the tectonic plate of the Africa, so evidence have shown that the African plate is rupturing into two new plates. The African plate, it is rupturing into two new plates. Like, let me just draw one diagram of it. Like, this is Africa. Okay, so that this is the Africa here. So it is rupturing from here. Okay, now this is rupturing from here. The plates are rupturing into two. Getting it? So few million years from now on, Africa will be split into two new continents. Getting it? What I'm trying to say? That is the thing. Also, the movement of the plates of Earth can occur in different ways. Like when two plates collide into one another like this, so there the plates are said to be like they are colliding into one another. So that can also cause earthquake. And here they are brushing past, meaning that moving away from each other, sliding past one another. So that will also cause earthquake. This is the way how the plates will be moving. And at some places, the plates will be moving in this manner also. They will be moving away from each other. Okay, so the movement of the plate can be of different types. One where they will be colliding into each other, one they will be sliding past one another, and one where they will be moving away from each other. Okay. Then talking about what is seismograph. So seismograph is basically the instrument with the help of which the earthquakes will be, like the seismic waves will be recorded. So it's an instrument that records the seismic wave. Okay, now we are going to learn about it with the help of a video. We'll be learning about it, how it basically functions. But first of all, let's understand its structure. So if we were to look at the structure of this now, like it contains a metal rod. Okay, it contains a metal rod in it. In this one, it is not visible. It basically consists of a vibrating rod. Okay, basically a pendulum that starts vibrating when tremors occur, meaning that this is a drum on which a chart paper is pasted. Just have a look at this one. That will give you better clarity. There is a chart paper here, okay, and this has been fixed on some stable structure. And this metal rod here, there's a this pendulum bob here. If you guys can see here, there's a pin attached just below it. Can you guys note down this thing? See, there's a pin right below the pendulum bob. And this pendulum bob is hanging with this string. It is hanging with this string. So it is containing this metal rod or this pendulum bob basically here, okay, which will be vibrating whenever earthquake will occur now. So this pendulum bob starts to vibrate, and there's a pin that is attached just below it. So whenever there will be an earthquake, the pendulum will be vibrating, thereby the pen will also vibrate, and those vibrations will be drawn on this chart paper. It will be drawn on this chart paper. Right now, in the form of waves, you can see those vibrations have been drawn on this chart paper, and scientists will be studying these waves, and they will then construct a map of the earthquake. And that map will help them determine the magnitude, determine the power of the earthquake. Are you guys getting this whole thing, how it basically functions? Just have a look at this video.
We know that earthquakes cause tremors on the earth. The tremors produce waves on the surface of the earth. These are called seismic waves. Seismic waves are recorded by an instrument called the seismograph. The instrument is simply a vibrating rod or a pendulum which starts vibrating when tremors occur. A pen or a marker is attached to the vibrating system. The pen records the seismic waves on a paper which moves under it. Trigger a mock earthquake on the table to see the seismograph in action. We can see that the pendulum tip records the earthquake on a graph sheet. In this activity, we have seen the recording of seismic waves caused by earthquakes.
Got this, all of you? How it functions? Yes? Is this clear to everyone? Please let me know if there's any doubt in this. Yes or no?
No, sir.
Good. Okay. Now, in fact, the seismograph, it has been developed as early as the year 132 AD. Getting it now? So it's not a recent thing. Like it's not an instrument that has been recently invented. Okay. Now, this is a very old instrument. It was invented by some Chinese scientists. I would say there were some Chinese scientists who developed it as early as 130 or 132 AD. Getting it now? So it was invented very early, and this will be basically recording those seismic waves. This seismograph records those seismic waves on a graph paper, and by analyzing it, scientists will determine the magnitude of the earthquake. Okay, now how strong or how weak the earthquake is. That is one thing. Okay. Now you guys know, like nowadays we have the concept of earthquake proof buildings. You would have learned of that, like you would have seen that nowadays earthquake resistant buildings are being made. So earthquake resistant buildings are also made, like basically on the base of the building, shock absorbers will be installed. Getting my point? Like shock absorbers would be installed at the base of the building. So whenever there's an earthquake, those shock absorbers will be absorbing the shocks and thereby preventing the building from collapse. Okay, now? Also, the type of material that is used in the building, that also determines that also plays a vital role in preventing the building from collapsing. Okay, no? That is the thing here. Like if I were to just give you a small idea of this, like suppose there's a building like this. Okay, so on the base of the building now, these shock absorbers will be installed. These are basically giant springs which will be acting as shock absorbers. So thereby they will be absorbing the tremors of earthquake, and hence prevent the building from collapsing. Okay. Furthermore, like the base has to be stable, meaning that whenever an engineer would be designing a building in a given area, he has to make sure that the soil and the rock under the building, okay, now that has to be stable. Okay, now otherwise, let's say if there is if the material is not stable during the construction, only the building might collapse. Many times you would have seen that under construction building would be collapsing. Okay. Why? Because the foundation is not strong, because the base is not strong. So the type of soil, it has to be studied. The basically the different layers of the soil, it has to be studied. Its density has to be studied. After that only the building should be constructed. Okay. Furthermore, we can reinforce the walls of the building by using steel beams in this manner. Okay, like steel beams, it can be fitted in this manner. Getting it? Like these are the different floors. So in the different floors, steel beams can be installed in this manner. Like we are cross bracing it. Okay, now like they have been fitted in a crisscross manner like this. Getting it? This is called as cross bracing. So this will This will reinforce the wall and make it stronger. Okay, so hope you guys have understood like how we can make the buildings earthquake proof. Okay, also one another important thing is that the weight distribution, the mass distribution in the building should also be proper, otherwise the building would be collapsing. So like the also another important thing, like the center of mass of the building, it should be at appropriate height. You guys getting what I mean by center of mass? Getting it? Like center of mass? Not getting it? Yes. You guys know about center of gravity? Yes. Center of the gravity, like it's the point in the body where the whole mass of the body will be concentrated. Getting it? So there will be center of gravity of the building also. So that also has to be at the appropriate place to make it shock proof. Okay. Now talking about the case of India. So there are some places in India which are more likely to be hit by earthquake. Okay, now particularly the northern part of India and the northeast part of India is more likely to be hit by earthquake. Hmm. So like states like you have Assam, states like here you have Manipur, Mizoram, then Meghalaya, Nagaland, and Tripura. These regions, these states are more likely to be hit by earthquake. Furthermore, states like Kashmir, uh, Jammu Kashmir, they are more likely to be hit by earthquake. Then Gujarat, that is also more likely to be hit by earthquake. The reason is that these regions are lying between the Eurasian and the Indian plate. So they are lying on the on the border of the Eurasian and Indian plate. So that's why they are more likely to be hit by the earthquake. Got this now? What I'm trying to say?
Yes,
So
sir.
so the regions of India, like if you guys can look at this one also. So these regions, like the one that is in dark red now, these are the zones where most of the seismic activity will be observed. So they are more prone to earthquake. Like the region of Kashmir, as you guys can see here, there's a dark, this is demarcated by dark red color. So the regions of Kashmir, then the regions of this western part of India, that is Gujarat here, then the central Himalayas also. Okay. Then parts near the Bihar, in Uttarakhand, in Himachal Pradesh, and this whole northeast part of India, northeast state of India, northeastern states of India. So all of these are falling in that zone where most of the seismic activity will be observed, and they have been put in the zone 5 where highest tectonic activities are observed. Got this or not? And in contrast to that, we see that the southern part of India, they are less likely to be hit by major earthquakes. Although they also are likely, but they are less likely to be hit by the major earthquakes. Hope you guys have understood these things. Okay.
Yes, sir.
Then what are the protections we have to follow whenever there's an earthquake? Like when you are in a outdoor, away from your house. Okay, so then you have to find a clearer spot which should be away from um, overhead lines, meaning the current carrying wires or the buildings, or if you're in a car, then you should go to a clear spot and you stay inside the car until the tremors stop, until the shaking of the earth stops. If you're inside the house, then you should stay under a heavy table or under a heavy bed till the tremors stop, and also avoid staying near the tall heavy objects. Okay, then what are the structural measures one can take? So if there's like some person is living in highly seismic areas, so they would be building house made out of mud, and the roof of the house should be lightweight in order to minimize the damage. Okay, now otherwise if the roof were to collapse on their head, they will be immediately dying. Okay, now so the structure of the building should also be designed by keeping this thing in mind. Like if they are living in a high seismic area, area where seismic activity is high, so in this manner the building should be made. Okay, now also fixed cupboards and shelves should be fixed to the wall. Okay, so that it does not falls whenever there's an earthquake. During an earthquake, some buildings would be catching fire, so therefore they must have proper working firefighting equipment. Okay, now, so earthquakes can also lead to fire in the building, meaning that if there is a short circuit, if there's a short circuit because of earthquake, so that will lead to fire also. So thereby we should have proper firefighting equipment like this. It's must to have a fire extinguisher at every home. Getting it now? Also, one should not use the elevator whenever there's an earthquake. In that case, let's say if the string of the earth of the elevator to were to break. Getting it? So if the string were to break, so the person will be it's most likely that the person will die. One can hide under a heavy desk. One should cover their head and neck with their hand like this. Okay. Stay away from these electrical cables. Do not stay at a doorway. Stay away from potentially danger objects like these objects here. Okay. Or if they are outdoor, they should drive. They are in a car, they should drive to a clear area and should avoid staying under a bridge because bridges are also more likely to collapse. Getting it now? So we have learned of those things. Now answer these questions. What is an electroscope? What are the different layers of Earth? And what is a seismograph? Yes. Should I assign these questions? Otherwise, you guys would be taking too much of time to answer. So I'm going to assign the questions. Okay. Alif, you answer the first one. Chakrika, you answer second. Gauri, you answer the third one. Okay. And Roni is left now. So Roni will be telling me about the regions of about which states of India are more likely to be hit by earthquake. Yes, you guys start.
So seismograph is an instrument which is used to measure the waves, like
Seismic waves.
seismic waves.
Okay. Next. Guys, don't take this much of time. Huh.
The Earth is made up of three different layers, and they are the crust, the mantle, and the core.
Okay.
The outside layer of the Earth is like made of solid rock. And there are two types of crusts, which are oceanic and continental crusts.
Very good. And which one of them is semi-solid?
So the
Mantle.
continental crust.
No, semi-solid. Mantle. Okay, I'm not asking about the
yes, sir.
continental and the oceanic. Out of the
Yes,
three
yes,
layers,
sir.
I was asking.
So it's the mantle.
Mantle. And convection currents will be observed in
the crust.
No. Convection currents, where the rocks and the hot molten magma will be moving.
So it's the crust, right?
No. This was the mantle in which the hot molten magma along with the rocks, along with the melted rocks plus magma.
So core.
No, you guys forgot about this thing. I
So
did.
outer metal or something, metal, right?
It is mantle. It is mantle, in fact. Okay, no? Like here, Fikrika and others, see, this is the crust of the earth. And right beneath the crust, we have the mantle. Okay. And mantle is extremely heated. It is heated because of the heat coming from the core. The heat from the core heats this layer. It heats up this layer. And the rocks and magma, it will be moving in this cyclic manner. Hot and molten magma, as it goes higher up, it cools down and again falls down. Just like the boiling of the water, the warm molecules of water, when it is heated, it rises up. When it comes close to the surface, it cools down and again falls down. So that is called as convection current. Now, we had seen that in the case of, you would have learned in the chapter heat, due to convection current, like transfer of heat takes place by conduction, convection, and radiation. You'd have learned about convection, I think, right? So here the movement of rocks and hot magma takes place, and this kind of movement is called as convection current. So mantle is moving, and because of the movement of the mantle, the crust is not stable. As we know, crust is made out of different tectonic plates. So whenever these like these tectonic plates will be colliding into each other, and wherever they collide, that area will experience earthquake, and the region where these areas will be colliding, that are called as seismic zones, because they are more likely to be hit by earthquake. Anyways, now who was supposed to answer this one? Electroscope. Yes, Ron, you have answered. In India, earthquakes are most likely to strike in Jammu and Kashmir, Gujarat, and Assam, and in fact, all the apart from Assam, all other states in northeast of India, like whether it be Mizoram, Nagaland, Manipur, Tripura, Meghalaya, Arunachal Pradesh, all of them are more likely to be hit by earthquakes. The reason being that they lie between the Eurasian and the Indian plate. They are lying on the margin of these two plates. Okay, who was appointed this question of electroscope? Alif, I think you. Okay, we are moving to the next part. Meanwhile, you
Sir,
answer it. Haha.
can you tell repeat again? Like why
What
did
is
you
an
told?
electroscope? What is an electroscope? Yeah.
Okay, sir, electroscope is like uh, finding the electrons in it.
Finding the electrons? No. Anyone
The
else?
charge.
Okay. Finding or detecting the charge, right? It's a device which can test if an object is charged or not. Okay. How does it work? Yes, Gauri, how does an electroscope work?
So electroscope is like it has two golden leaves like that. So like when and positive or like charge object comes in the contact of electroscope, so the leaves diverged,
Mm-hmm.
and when it is touched by hand or touched by any another charge, like if it's like a negative charge, so leaves will gonna come on their original place.
So say that you had brought a positively charged rod in contact with this right now. So at that moment, all this gold foil leaves, now it became positively charged, so they will be diverging from each other. But once I touched the metal disc, so electrons will transform from my hand, like it came from the earth, and via my body, it will go into that metal disc. So thereby, the number of charges in this will become equal. So thereby, this will now come to its original position of rest. Now, when you had brought a negatively charged ebonite rod, for example, here, so these are getting repelled from each other. Then also they get diverged from each other. But once I touch my hand, now here what is happening? Now the electrons from this, the negative charge from this goes via my hand into the earth. So this charging is happening here. Okay, now getting it. This charge happens here. And in that case also what will happen? It will then come back to its original position. Okay. So that is how an electroscope works. By the divergence of the gold foil leaves, we can detect the presence of it. Yes, Chakrika?
So can we use any other material like except gold foil leaves?
Yeah, of course, we can have any other material apart from this. Like you can even do it with a sheet of paper.
So is it necessary that the charges should be the same?
The charges should be same.
Yes, sir.
Like by working, it is seen that they will be acquiring the same charge now. Like when I will bring a positively charged rod in contact to this metal plate, it is obvious that both of them, since they are connected to this rod now, so they can't acquire other charges. It's not like one of them will be acquiring positive, other one will be acquiring negative. Both of them is in contact with the same metal rod now, this metal rod.
Yes, sir,
So
but
they will
like,
be
isn't it possible for them to be charged negative?
for the gold file leaves, you are saying.
Yes, sir, or any other substance.
No, by the design, when you look at the design of spectroscope, it is not possible. Okay, no? When we look
Yes,
at the
sir.
design, it is not possible. Okay, both of them
Yes,
at the same time either can be both, either both of them will be charged with positive, or either both of them will be charged with the will be negatively charged, depending upon the material you have brought in contact with the metal disc here.
Oh, wait. So, sir, like the charged rod, it can be either positive nor negative, right?
It really depends upon, like, you have taken a glass rod. Say that you had
So,
taken a glass rod and you rubbed it with silk. So the glass rod acquires positive charge. But then you have a
yes, sir.
ebonite rod. When rod is rubbed with silk or wool, it acquires negative charge. Okay, now,
Yes, sir.
that is the thing. Okay, now moving on to the next topic. We had some questions to do, then we'll be moving on to tsunami. Okay, you guys answer these questions in the chat box. All of you start answering it as quickly as possible.
Sir, in the chat box.
Yeah, in the chat box. By the way, Chakrika and Roni, will you guys be available today for the extra class for the chapter materials, metals and non-metals?
No, sir.
Not today. Okay, so when you will be having your next class, then will you guys be available?
Maybe, sir.
Maybe. Chakrika, what about you?
Sir, I might be most probably.
Okay. See, both of you have to be present in that same class. Okay, na? Because both of you have to attend the class. I mean to say, okay, we can't have like separate class for both of you. So it is important that both of you are present on that same day. Okay. So for today it's not possible, but do let the team know before the next class. Okay, na? They will share a reminder to you. Okay, na? And do let them know whether you guys will be available in the next class or not. Okay, for the first one you guys have answered. Shukriya, that is correct. Gauri, that is correct. The second one is also correct, Chakrika. Good. Yeah, everyone answer it quickly. You guys have to answer on this ID, not on the other one. Yes, Gauri, that is correct. Yes, what happened to others? Okay, Alif. That is correct, Alif. Yes, Roni, you are left to answer. Just write the option number. Okay, I'm moving on to the next then. Answer these questions. That is correct. Yes, Gauri and Chakrika, that is correct. And Alif, what have you answered for the first one? Read the question once again and then answer it.
Okay, sir.
Roni, are you there in the class? You haven't been answering.
Oh, sir, like,
Sir, I'm answering the chat box.
Okay, you have messaged.
Yes.
Just 1 minute. So you don't have to message on this one, no? So you are messaging on this one. So I will have to switch the screen to this in order to look at it. Okay, now. So you have to answer on this one. Like, okay, you can see here. See the one, this one. Okay, now. The third one, Sohail, that is co-host. You have to answer on this one, okay? Okay, meanwhile, just
Sir,
let me look at your answers.
I accidentally swapped the answer, like put the B1C, like confused.
Okay, okay, no issue. By the way, Roni, your answers are correct. Right? For the fourth one, you guys have answered C, that is correct. Okay. Now, fifth and sixth, answer these ones also. Fifth one, you can leave this right now, okay? Because we are about to learn this one. Okay. You can answer sixth one. Skip the sixth one, fifth one. Correct, Gauri. That is correct. Roni, the Earth's plate responsible for causing earthquake. It's the mantle of the Earth, no? Mantle causes the earthquake basically due to the movement here. Getting it now? Okay. Okay, we have some time left, so we can continue with this topic of tsunami. Okay, now. Tsunami, as you guys can see in this video here, like it's a series of waves in a water body that is caused by displacement of large amount of water, large volume of water. Generally, it occurs in an ocean or can occur sometime in a large water body, like a large river also, not a lake usually. Earthquakes, volcanic eruptions, and other underwater explosions, like when there is a, let's say, nuclear explosion that is carried under the ocean. These can bring a tsunami. Okay, now so these activities have the potential to generate a tsunami. Getting it? Whether it be earthquake or underwater volcanic eruptions and other underwater explosions, all of these carries the potential to generate a tsunami. In tsunami, T is silent. Okay, now T is silent in this. Okay. Also, like you guys would have learned, like volcanic eruptions can occur inside the earth also. I mean to say inside the oceans also. Getting it? Volcanic eruptions occurs under the oceans also. Although we don't get to hear of this, but volcanic activity occurs deep inside the oceans also. Got my point? What I'm trying to say? Okay, like you might have heard of Pacific Ring of Fire. You might have heard of Pacific Ring of Fire. Like Pacific Ring of Fire is a kind of a belt of earth, belt of volcanoes under the ocean now. This is also called as Pacific Ring of Fire or simply Ring of Fire, where earthquakes should be happening, where volcanic activity would be happening. Just let me show you a video here. Show me you this image here of the Pacific Ring of Fire. In geography, have you guys heard of this?
No, sir. You can repeat?
Pacific Ring of Fire.
Maybe no. No, sir.
Okay, let me just show you this thing here. See, this is Pacific Ring of Fire, or basically called as Ring of Fire. See, basically in this, what you can see here, like it's a belt of volcano here, and it's about 40,000 kilometer in length, about 40,000 kilometer length, and it is surrounding the part of the Pacific Ocean. This is the Pacific Ocean here, and this contains so many active and dormant volcanoes. There are about 800, 900 active and dormant volcanoes in this ring of fire. Getting it now? So when divers, when we go to observe this area, na, if I were to go under the ocean and observe, I will see that fires should be emerging out of these areas. Getting it, guys? So that is called as a ring of fire. That is surrounded by this these regions here. Okay, it is between the Australia, between the South America and all these region here. So it surrounds the Pacific area, and here tsunamis would also occur in these areas. Okay, now tsunamis would also be common in these areas. So that is called as Pacific Ring of Fire. It's a 40,000 kilometer belt of so many small volcanoes, and earthquakes will also be common in these regions. So if there's earthquake and volcanic eruptions here, so it is obvious that this will lead to tsunami in this region also. Getting it now? And it is obvious like why this is called as ring of fire. Because once when we observe it now, when we go there and observe it, so like volcanic eruption, there is a whenever there's a volcanic eruption, lava comes out now. There will be lava, fire would be there. So that is why this is called as a ring of fire. Okay, hope it is clear. And where is it situated? It is situated in between countries like, as you can see here, it is situated in countries like in places like between Indonesia, Australia, and here you can see like there are countries like Mexico here. Japan is also here, like Japan is over here. United States is also there, Canada, Russia. So in between these places, this ring of fire is situated. So we'll be continuing with the topic of tsunami in the next class, where we'll be learning about how it is caused, okay, now how the plate movement will trigger the tsunami, and what are some of the important terminologies related to tsunami